This is my presentation for assignment 1.3, performance patterns. My name is Patrick Way. The variables I will be focusing on during this presentation will be country, gender, run rank, swim rank, division, and bike rank. These values are pulled from data sets for the Ironman of Arizona for the years 2015 to 2019. The first variable correlation we'll go over is country. It received a 0.07 correlation value for overall rank, and then the values correlate to these guys right here. So the countries that won, or had winners rather, are Canada, Spain, and the United States. Next variable is gender. Received a 0.24, almost 0.25 value for the correlation. And then over here on the graph side, we can showcase that it appears only males have won the Arizona Ironman during the years of 2015 to 2019. Division rank received a 0.35, almost 0.36. One thing that I should have thought about with division is that if you win the race, you're probably the first in your division. So this variable ends up not being very useful and kind of gets pushed onto the wayside simply because it's always a one if you're a winner. So yeah, I don't know. Had I thought about it more, it probably would have been something I could have disregarded, maybe focused on something else, but I guess that's the nature of analysis. Swim rank doubles the prior values correlation at a 0.7. The swim rank has a variance to it, ranging. So we got like 31 to 25, 7, 4, and the 2. It's got a nice wide range to it. One thing I found interesting with this is that it appears nobody that has won the swimming has actually ended up winning the race. So it's kind of interesting. Might kind of emphasize like you might be putting out too much energy right there at the beginning. But either way, biking follows up at an even higher value of 0.9. We have a smaller range of 3 values, 3, 7, to 1, being the ranks that biking individuals have been able to win with. This one's kind of cool because biking was, if you do win the biking, there is a chance that you could end up winning the race overall. It makes that much of a contribution, it appears. Followed up with running being a little bit higher at a 92, almost a 93. And then again, a smaller range, the 19.2 and 1. It's cool to see that, it's almost like it would stink to, I guess, in a sense, be number one to get across the finish line in the run side and then find out you've gotten like last place, or that's unrealistic. But in this case, getting first or second, there is a chance that you could potentially get, or you can end up winning the competition overall. But it also is a nice alternative highlight with the 19 is that just because you're not first at the end of the run doesn't necessarily mean the world's over. There are options. So it's the running is kind of cool to see the variance, I guess, in this aspect. So followed up with variable regressions. So gender hit a 0.01. There's only one gender being kind of represented within these populations. So I can kind of understand where the issues are coming in from. Division rank is, we would think, would be similar considering the nature, but it received a 0.3 for its coefficient. The variable regression, it received a 0.07 for country. Again, the 3 countries being Canada, Spain, and the United States. This doesn't seem to be a very useful item. Swim rank didn't pull in the value I thought it would. Swim rank pulls in a 0.024. I guess that kind of goes with that first notation within the correlation, in that, what do you call it? Nobody technically is one, with a number one swim. So the swim rank is a little bit more sporadic. It kind of, I guess, in a way, it's setting the foundation for the different athletes and their abilities. Bike rank, we kind of almost condense all that cluster, or all that lack of clustering rather in the last one, into a cluster that is similar to a line, kind of showing the, not a one-to-one, but that there is a correlation between bike and your rankings. And then you've got your outliers up there at the top that are kind of, craziness, I guess. Then followed in with, again, this one is, it's condensed, it's not as thin as the biking one was, as a coefficient of 0.21. But you do still kind of see the line, and it kind of does show that there, that correlation is present. I understand we had a point, was a 9.2 value for run rank, but it's cool to see that one analysis translates into another, I suppose. So who would have the fastest, what is the likelihood if you have the fastest swim time? Kind of went over that already, in a way that nobody's technically won with the fastest swim time. So if you were to go and compare the populations, so here's everybody who's essentially had the best swim time across the years that so across the years that had number one. So what do you call it? There was only 3 contestants that had the fastest swim time. What do you call it? 0 winners, so 0. Followed up with, then we had 1 contestant that actually took second with the fastest, what do you call it, swim time, and then they, what do you call it, were able to receive a 0.33, or that, so that would give us, excuse me, that would give us a 0.33 or a 33% chance that if you do get the fastest swim time, there's, based off of the population, there is a chance that you could end up very well within the top 3. And then there was no 3rd place contestants, and then there was nobody that won. So if you do win the swimming, there's a chance you could be in the top 3. But if you do win the swimming, there's also a chance you might have, used up too much gas, and it's going to end up, shooting you in the foot. Followed up with biking is the data set of biking individuals that have taken first. So something to know is, so in this set and the prior set, we don't have 5 values. The reason for that is these data sets have been trimmed down to only include individuals that have an overall rank within the top 25 of each year. That way, I was able to use the regression and correlation tools within Excel, and I tried to use all the values that I was able to gather from the data analysis. I unfortunately was not able to fully process or utilize the tools. So that would be why in some of these instances, we only have 3 versus maybe 5 contestants. So we did have an individual win, and we had an individual take 3rd. So we take those over and we kind of look at them again, and we compare them to the populations we have. So if you do win the bike, there's a 33% chance you could end up in first. We didn't have anybody take second with the bike with winning. So as of right, with this population, there's a 0, followed up with another 33 for 3rd place because we had 1 contestant hit. And then because we had 1 contestant out of the 5 winners, you have a 0.2. Same thing per run. This time we actually were able to get 5 individuals, which I thought was pretty great. Followed up with their overall ranks being pretty awesome. I know the 11 isn't ideal, but these, what do you call it, races have like roughly 2,000 people. So like 11th place is still pretty awesome. So we take this population and we pop over. And so for 2 winners out of 5 contestants, we get the 0.4. So if you have a fastest run time, it clearly it clearly adds quite a bit to you or your chances. Followed up with second place. You know, we had two contestants. So again, I mean, another 0.4. So you have a really good chance of being in the top three if you have, what do you call it? The number one runtime. The last one, we didn't have anybody take third. So we get a 0 there. And then two winners were actually able, or two people were actually able to win with the fastest runtime. So again, we get a 0.4 for the population of 5. So I would recommend that they focus on biking and running because those have the highest probability of getting in the top 3 if you are able to get the number 1 spot within your heat or within your race. Is a list of all my, or of where I was able to extract the data for this analysis. Thank you for attending my presentation.